All right, so as we start in with Unit 9, congruent triangles, this is our final unit for the semester. So we're defining triangles based on their interior angles, their exterior angles, and also the corollary to the theorem. We're going to have classifying triangles based on their sides, as well as their angles. And then we're going to use the triangle sum theorem and exterior angle theorem, which we've already talked about previously. So here we are. We're going to classify triangles using the sides and angles. So starting in, we have the scalene triangle. That means all sides are different. Okay. And I depict that by showing like 1 tick mark, 2 tick marks, and then 3 tick marks. So they're all different. An isosceles triangle is going to have 2 sides equal, which also means you're going to have 2 angles that are equal, but we're working with sides only here. So this is all about sides. And then equilateral. Lateral means your sides again. So that means all sides are equal. And then classifying by their angles, we have acute, obtuse, equal angular. We also have a right triangle. So an acute triangle means we're going to have all less than 90 degrees. All angles will be less than 90 degrees. Now a right triangle means we're going to have one right angle. And when I say right angle, I mean 90 degrees. Usually depicted with a box. This is just going to be your typical obtuse triangle. We're going to have one angle is greater than 90 degrees. Such as that one. An equal angular means all angles are congruent. Or equal. And it's going to be, if I get my pen to write, all angles are the same. Now the triangle sum theorem, the 3 interior angles, 3 interior angles of a triangle add to 180 degrees. The exterior angle theorem, that's when we did, I think we did this earlier. Oops, we did this earlier. If this is A, this is B, and this is C, and this is D, I'm going to say that A and B here, these are our interior angles, but they're the opposite interior angles of my exterior angle. And we can say that these two added together, so A plus B is equal to D, because C and D add up to 180, and ABC adds up to 180. So if I take out C, AB equals D. So in this case, an exterior angle of a triangle is equal to the opposite interior angles added together. And then we have a couple of sample problems here. We're going to have a couple of each. These first two are the sum, interior sums. So the triangle sum theorem says that x plus 132 plus 20 equals 180 degrees. So when I solve this, I get x plus 152 equals 180, x equals 28. When I take away 152, take away 152. The next one is going to be similar, x plus the 2x plus x plus 20 equals 180 degrees. Remember, you have to combine your x's, so x and 2x and 1x, that gives me 4x plus 20. So 4x equals minus 20 minus 20, 160. Divide by 4 on both sides, x is equal to 40. Now keep in mind, this x, that is 28 degrees. However, here, this is 40 degrees. This is 2 times 40, so this is 80 degrees. And this one would be 40 plus 20, which is going to be 60 degrees. So make sure that you're finding angle measures. Go back and actually find x and then plug it back in. This next set, this is the exterior angle theorem. So we know that this exterior angle is going to be these two added together. So we can say x plus 80 equals 3x plus 6. Make sure that you solve for x. So take away an x, take away an x, minus a 6, minus a 6. So these go away and these go away. So 74 is equal to 2x. X is equal to 37. So x is 37 degrees. However, this would be 3 times 37 plus 6. Oops. Get my eraser out here. There we go. I wrote that a little bit wrong. There we go. So 3 times 37 is 111. So 111 plus 6 is 117. And over here, if I did 80 plus 37, I get 117. All right, my pen is not working so great, so I'm going to continue this with just writing with my finger, basically. So, as we look at this next one, we're going to take the 2x minus 5 is going to equal the x plus 70. And when we solve that, that looks really ugly. When we solve that, line down the middle, take away an x from both sides, and you solve it, and you should end up with 75. So x is going to equal 75. And we're almost done. That's why I'm going to keep on going here. This last one, don't forget that this is a 90 degree right here, and it's a sum. So we're going to say 90 plus 2x plus x minus 6. And that's going to equal 180. When you solve that, you should end up with x equals 32. And the last question it asks you down here, what generalization can you make about the two acute angles in the right triangle? Well, think about it, a couple things. If that one's 90 and they add up to 180, together those other two angles have to equal 180. The other thing is that they both have to be less than 90. So other angles must be less than 90. They have to be acute.